All right. The late start today because of the ice, we got a little bit behind. So let's talk about the important ideas here. With significance testing, there are 4 steps, and that's actually big idea number 1. And actually, most of this is going to be big idea number 1. So we'll talk about that here in a second. 4 steps. So out of the 4 steps, you've got this. First of all, we do this, and actually you can see this on the previous page. You're going to go through and you're going to state everything. So in this case here, we've stated a parameter. What are we testing? What our stat is that we're comparing it to. Our hypotheses. And the alpha value that you want. You want to write it out at significance level. Second part is you're going to plan this out. So now that we know what the basics are, the 2 things that you need to know is you need to make sure that you hit the name of what we're talking about. So like in our example, the 1 sample z-test. For proportions. And then after you do that, you run through the conditions. Why can we use it? Are we meeting all the conditions, etc.? And then you're going to go through and you're going to run through all the calculations. So you're going to do the do. And again, remember the order that we want to do these in. We want to do the general. We want to do the specific. It's going to be recommended that you do the picture next, because that way you can make sure which direction we're going. And you're going to do the work. Your answer is going to be twofold. You've got your test stat. Which is going to look a lot like your z-score. So again, it's going to be our stat minus our null divided by your standard deviation. And then you're going to go through and do the math. And so in this case here, for proportions, it's going to be p hat minus p, all divided by our standard deviation, remember, which is p times not p all over n, and then 2 to the square root of all that. And then the last thing you're going to do is you're going to conclude, because after all, the numbers are fine. Explaining them are better. So otherwise, you just get people with glossy looks. And if you can explain numbers, let's face it, people are going to pay you to do that. So we do or do not. Looks like donut, sorry. See, these are the little things you're going to remember. I almost did it again. If I had time, I'd go back and edit that out. But let's face it. We do or do not have convincing evidence. Against our null hypothesis. Again, we're not proving that it's true. We're assuming that it's true. So either you say it's true or it's not true, or you say it's either not, can't disprove it, or you can prove that it's not. Doesn't make sense. Last little thing over here, which we're going to actually do down here in the check for your understanding. Big idea number 2. If it's a 2-sided setup, so you're saying that we don't care if it's less than or greater than. So far we've only down like we're testing that p is less than or p is greater than. Let's say if it's, we just care that it's not the number that we're saying. what we're going to do is that we're going to go through and we're going to multiply couldn't read my notes there. The p-score by 2. Because again, if that's the case, we've got this. We're looking over here and over here. So if we know one area, we double it. And I suppose we could do that over here. P-score is either your table, your z-table, or normal CDF. Pause when you need to, and then we'll jump into the problem that we didn't get to today. So, according to the National Institute of Occupational Safety and Health, job stress poses a major threat to health of workers. The news report claims that 75% of restaurant employees feel that work stress has negative impact on their personal lives. Managers of a large restaurant chain wonder whether this claim is valid for employees. The random sample of 100 employees find that 68 answer yes when asked. Does this work have a negative impact on your personal life? So first of all, does this data provide convincing evidence at an alpha value of 10? Yes, I know we talked about 5. This will make sense in a second. Significance level that the proportion of all employees in this chain who would say yes differs from 7.5. This right here doesn't say is less than or greater than, or I mean less than or bigger than, differs. So that means that we're doing both bigger and less than, so that's two-sided. In fact, I'm going to even highlight that for you. There. Sound effects are optional. So for stating the parameter here, again, remember parameter, we're not actually going to have a number value for it. We're just going to go ahead and we're going to just explain what's going on. The parameter P is going to be the true proportion. Yes, you have to say true proportion. Of employees who say yes. And if we had more room, we could say yes, work stress impacts my life. Now if you look back up here, we suggested that, so you do parameter stat. So our stat here is going to be 60 answer yes out of 100. So p hat equals 68 out of 100. There. Get rid of that stray mark. Now your two hypotheses are this. So hypothesis number 1, or your null hypothesis, is that P is just simply 75%. Our alternate hypothesis is that P is not equal to 0.75. So that goes back into this differing thing. We don't care if it's less than, we don't care if it's greater than, we just want to know, is 75% an accurate number to use in this case? And then our significance level over here, we already have set it up, and again, they'll tell you. If they don't, then you can assume 5% is usually good, but they ask for 10. So plan it, name it, check conditions, name of our procedure. We have one sample, so it's going to be one sample. So again, how many samples do you have? What type of test are we running? So in this case here, we're doing a z-test, so we're going to do a z-test. Since it's a proportion, we can figure out what the assumed standard deviation would be if it was 75% in 100 people. And then 4 proportions. It's like your thesis statement. This is what I'm going to do. Conditions. Is it random? Check. Why? Because they say, and I quote, a random sample of 100. %% rule. Why do we need 10% rule? That's the independent part. So we are going to assume there's that. So we're we're going to assume that 100 is less than 1/10 of all employees. And the last but not least, large count. Can we treat this as normal? So again, n times p. Oops. It's reading backwards. And then n times not p. And both of those are bigger than or equal to 10. Check. Check, check, check. So in terms of the work, yes, I need to give you more space next year. I'm sorry. So what's your test stat? To find our test stat, remember, it's always going to equal your stat minus whatever you know hypothesis is, all divided through by whatever our standard deviation is assumed to be. Our specific formula over here in this case, z p hat minus p divided by standard deviation. In this case, remember, it's going to be p times not p divided by n, square root of all that. So you're going to do all your work. So in this case, our z-score is, we found the p hat of 0.68. We're going to subtract off the 75% that we assume is p. And over here, again, since we're assuming we're testing the null hypothesis, we're going to use the assumed p-values. When you do all of that, you should end up with a negative 1.63. And again, if you're going to, I wouldn't do that all at one time. I would do the standard deviation on the bottom, do all that, and then divide it. But that's just me. Your picture here is this. I remember we said it was two-sided, right? So we've got this right here of 0.75. So we've got this over here is 0.68. Now, it's reasonable to assume that if we're looking for differing, the chances, and we don't care which side of the mean that we're on, or p that we're on here. So it could be that side, but it could also equally be over here. So how unlikely that what we saw would have been one of these wings on either side. So again, this is what two-sided looks like. Sometimes people say two-tailed. So the z-statistic over here is this, or the t-statistic is the z-score, which is going to be a negative 1.63. If you go through and you do that off the table or the normal CDF, you'll get a p-value here of 0.0516. Now remember, that's only that side right there. So we want to go times 2. Oops. Because we've got 5% in each one of those. So then in this case here, I've got just over 10%. So your conclusion in this little tiny spot. You're welcome. So assuming that the proportion of employees who answer yes to the stress test is equal to 0.75, there is a 0.1032 probability. No, Mr. Hayes. Of getting a sample proportion as far away as 0.68 or further by chance. I know. Type it, Mr. Hayes. Here's the key right here. We fail to reject the null hypothesis. When I was at a workshop, they said if you don't write that down, you may run the risk of not getting a 4 on a problem. Do we reject the null hypothesis, or do we fail to reject the null hypothesis? Those are true. Those are the two big things there. Okay? Now the bottom one, let's just talk through that, and I'll let you write it down. So 90% confidence interval for restaurant worker data was also created and was found to be between 0.603272 and 0.756728. Explain how the confidence interval is consistent with but gives more information than the test. Okay. Couple of things. So what this does, what the confidence interval does is this. So first of all, it's plausible because our 0.75 that we're looking for is inside the interval. If that wasn't the case, then we're stuck. Okay. So, because I like you guys. Okay, so a couple of things. So one, oops. Let's see, the null value is in the interval. So it's plausible. Oops. Sorry, I got distracted by it because I didn't name my pronoun. So the confidence interval is plausible. So there's that. Second part. Okay, so great, it's plausible. So what does that interval mean? Okay. What the interval actually does is it gives us other plausible values for P. Plausible values, or in this case, P as in the values for the null hypothesis. So what this is saying is that if you do a confidence interval, you know that the true mean is somewhere between 0.6032372 and then 0.7567627 or 7566728. So since the true mean is somewhere in there, we assumed it was 0.75, but we don't know that for sure. We know it's somewhere in there, so then that's going to give us some other potential things that we're using for the null hypothesis. Now, how does that tie in with what we're doing in terms of significance testing? It's kind of similar because what you're saying is that, all right, since we know all the plausible ones are from here to here, then the question then becomes, all right, is what we're seeing plausible? So up here, we're saying, okay, so we assumed it was 0.75, 75%. We saw 68%. Is that plausible? Yeah, it is. At a 10% level, yeah, I'd say it's plausible. It makes sense. We could see it. So that's kind of how those two are related. If I were you, I'd probably go back and read that or listen to that a couple of times to be safe. So again, the confidence interval again, we're trying to find a confidence interval that contains the true value P. Significance testing is what we're seeing plausible. If it is plausible, then we're going to fail to reject the null hypothesis. If it is plausible, or if it's not plausible, then we're going to reject the null hypothesis. So anyway, a lot there. Enjoy. We will see you tomorrow, and we'll start to wrap this up. We're going to start moving in. Instead of doing it with proportions, we're going to talk about doing it with means. And so then we're going to have to worry about, do we know the standard deviation, et cetera. So a lot of the stuff we do with confidence intervals are going to come back. We're just going to rework it in a different direction. Talk to you soon.